So for a school project, I had to take 30 days and learn about something new. I chose to do C++, which I am familiar with programming languages, not at all with C++. I chose to do C++ because of just how versatile it is and how powerful it is. It's used in almost everything. In the Complete Coding Manual, which is the book that I chose to learn from, on page 100, why C++, due to both the complexity of the language and its power and performance, C++ is often used to develop games, programs, device drivers, and even entire operating systems. Basically what that means is that pretty much everything on Windows, on Linux, everything is made in C++. Any kind of games you would play, Borderlands, Fortnite, Counter-Strike, the new Valorant game that came out, Animal Crossing is probably done in C++. Mario Kart's probably done in C++. Everything is done in C++. A famous example of how powerful C++ is and how it's integrated into every operating system is there's a one-line command that you can enter into the Windows command prompt that will just play Episode 4 from Star Wars in the command prompt as ASCII characters. The ASCII characters are animated. It's just text, basically. Somebody took the time to animate ASCII characters through the entirety of Star Wars Episode 4. It's really cool. Don't watch it all the way through, but like the first couple of scenes, really awesome. Because there's no sound that's in the Windows command prompt, but it's really, really cool. Alright, so now we're going to be installing an IDE for C++, which is essentially just a fancy text editor. All it is, it's going to be allowing you to directly execute the code from the editor. You won't have to exit the code editor and then go open the file specifically in a certain spot. You want to go to your web browser, just type in codeblocks.org/downloads. Alright, so what you want to do is you want to go to codeblocks.org/downloads. Wait for it to load. You want to download the binary release. Scroll down. For Windows, it's right here. If not, click on your specific thing. I'll take you right to it. I'm going to use FossHub, SourceForge. Doesn't matter which one you select for the download from. Just click it. It should automatically download. You want to save it to your downloads folder or whatever folder you prefer. Run it from your browser. Alright, so once you run the codeblocks.exe file, this window will pop up. Pretty easy, just a spam next window. Don't have to do any fancy stuff. Once it's done installing, there is a couple of extra windows that are going to pop up that we need to go through, but not too difficult. Shouldn't take more than about 30 minutes tops for this to happen if you have a really slow hard drive. So there are a couple of other dialog windows that might pop up. The first one is going to be a dialog window that is going to be titled Compiler's Auto Detection. I'll have a picture of it from the book up on screen now. Pretty simple. Just make sure that at the bottom of the screen it has the default compiler set to GNU GCC compiler. If not, you want to select it. It should be the top of the list in the little thing there. And then click Set as Default and then click OK. Once you've done that, should open right up to this screen here. There may be another dialog box asking you what compiler it wants you to use. Just select C and C++ and click OK. And then you're in CodeBlocks. Alright, so now we're going to do the first program. So your first program is always going to be a hello world text to the console. That's just how it is. You don't question it. So first thing you want to do, you want to go to File, New, Empty File. You want to type in hashtag include IOStream. Go a couple lines down. Int main with parentheses. Then you want to open bracket, close bracket should automatically be there. Enter a couple times, go in here, press tab. Always keep your tabs properly. Just type in std :count space, two of these guys, hello world. And then if you want to, you can do \n, which will set a new line. And then make sure you have a semicolon at the end, and you're good to go. All I gotta do now, File, Save File As. I created a new folder in my documents called C++ Programs to save it to. All you gotta do, rename it however you want. I'm gonna name mine Hello World. Pretty simple. And you're good to go. Hi, Post Ethan here. My mistake, I accidentally capitalized all the letters at the beginning of the lines in there because I had auto capitalization on for that. That's my mistake. It's not an issue with the program. I had another program running that did that. So make sure that everything is in lowercase in your program, and make sure you save your file as a .cpp file, not a .c file. So once you have your program written, all you gotta do, click the cog and the arrow that will build your program and run your program all at once. So give it a few seconds. Might take a minute. It'll open this command prompt window. It's already done. See? Hello world. There's a new line there. If you didn't put new line, the process returned will be directly underneath hello world instead of that space. And that's the program. You can put whatever you want in here. I'm going to put hello again after hello world. Build and run. Boom. See? Right there. Done. All right, so we're going to jump ahead just a little bit here in the book because this is more relevant to what we're going to be talking about right now in terms of printing to the console and stuff. So character literals are basically inside of the code. You type a / and then you can type your character in. So if you want to put quotes, for example, into your text that you're displaying on the screen, you would put a / quotation marks. Or for a question mark, because that's used in the C++ code, you would need to put a / first. Essentially, if you want to put a special character into anything you're printing out to the console, it's important to make sure you put a / beforehand. You can even do that with Unicode characters. All you got to do is you put a / and then the Unicode code after a U, so \U and then the code for the Unicode character. So if you wanted to put the symbol pi in your printing, you would do \U and then the Unicode for that character. So you can print pretty much anything to the console. So we are going to start working on variables now, which are very important to any coding language or any kind of programming you're going to be doing. So you're just going to want to create, to start with, you just want to create a basic program, super simple, just the outline of everything that we used in the other program, except you want to make sure you add using namespace std underneath the include IO stream. So once you're in this, once you've done this part, you want to add int a, which creates a variable called a, and int b, which creates a variable called b. Okay. Next, we're going to do set a equal to 10, and then b equal to 5. Pretty simple. That's variables, pretty much everything. So, super easy. What we can do is we can just simply say count a, and it will print the variable a, or count b, and it'll print the variable b. Oh, I'm going to add a new line here. Now notice how when I want it to print just the variable, I don't put it in quotation marks. If I put it in quotation marks, like watch. If I put it in quotation marks, what it's going to do when I compile and run it is it is going to print the letter B. It's going to print the letter B. See, it printed B instead of 5, whereas with A, it printed 10. All right, we've done that. We've got our printing out just the variables. So what we're going to do now, pretty simple. We're going to make another int called result. And we are going to set that equal to A plus B. And then we're going to count result as well. So now it's going to print 10, 5, and 15 when it's done compiling. Oh, I forgot to do a new line. That's my bad. So it's going to print 10, 5, and 15 now into the console. See, 10, 5, 15. Pretty cool. So there is another way to assign values to variables, which is using parentheses. I don't usually use this. I think it's easier to just set it equal to. I find that much easier, but you can say like int c and then just put 10 in here to have int c equal to 10. I don't think it's as intuitive as just putting equals, but you do what you feel is better. So next thing we're going to talk about data types. There are 8 different data types: integer, floating point, character, double floating point, wide character, void, which basically means null. It's more 0 than 0, if that makes sense. And then there's string, which is like a sentence. That's what we were printing to the console, was a string. They can be extended using a couple different modifiers. We're not really going to be talking about that too much, but they can be extended using long, short, signed, and unsigned. They can expand the minimum and maximum range of the values, so you can make a number larger than would normally be allowed in C++. There are set values for that. On page 126 of my book, it says that all of the modifiers for an unsigned int is 0 to a large number. I'll put it on screen. I don't even know how to say that. Signed int, negative large number to a positive large number. Short int is just a smaller range of ints. So it's a smaller negative number to a smaller positive number. That's only 33,000-ish that it goes up to. Unsigned short int only goes up to 65,000. Signed short int is 33,000 negative and positive. Long ints are ridiculously large, negative and positive. Signed long int even larger. Unsigned long int is the same as an unsigned int. You can pretty much use the defaults for everything unless you're using ludicrously large programs. They would have to be incredibly large for you to want to change the values. Sometimes changing the int type to smaller can actually help save on resources. Generally, it's not necessary, but if your program is particularly heavy, doing that can help sometimes. We're going to be talking about strings now. Strings, super important. The really only other way to print long sentences or long words without strings would be to save each individual character in a char, C-H-A-R, variable, which is not fun, and then you just put it in a for loop that just keeps printing out the next character. It's super annoying, super not fun. We're not going to do that. So make a new program. Save it as whatever it is you want to save it as a .cpp file. I just have mine as untitled still. Not a big deal. All you do for a string, it's pretty simple. String greet, for example, if we're greeting, we're making a greeting, equals hello. Boom. String. We want to print. Pretty easy. All we gotta do, count, greet, \n for new line, boom, compile it. Oh.
For the touch of your lips, dear, but much more for the touch of your whips, dear. You can raise welts like nobody else as we dance to the masochism tango. Say our love is a flame, not an ember. Say it's me that you want to dismember. Blacken my eye, set fire to my tie as we dance to the masochism tango. At your command, before you here I stand. My heart is in my hand. Yeah. It's here that I must be. My heart entreats. Just hear those savage beats, and go put on your cleats and come and trample me. Your heart is hard as stone or mahogany. That's why I'm in such exquisite agony. My soul is on fire. It's aflame with desire, which is why I perspire when we tango. You caught my nose in your left castanet, love. I can feel the pain yet, love, every time I hear drums. And I envy the rose that you held in your teeth, love, with the thorns underneath, love, sticking into your gums. Your eyes cast a spell that bewitches. The last time I needed 20 stitches to sew up the gash you made with your lash as we dance to the masochism tango. Bash in my brain and make me scream with pain, then kick me once again and say we'll never part. I know too well I'm underneath your spell, so darling, if you smell something burning, it's my heart. Won't you take your cigarette from its holder and burn your initials in my shoulder? Fracture my spine and swear that you're mine as we dance to the masochism tango.
Oh, I did Sting. Alright, here's what you gotta do. Create your program, save it as .cpp, right? All you gotta do, string greet, we're gonna do greet, equals hello. Right? Super simple. Next, we're gonna print it out, count, greet. Boom. Ready? Compile. Bam. Compiled, it's going to print out hello. The other option is to make a lot of individual car variables that are super annoying to deal with, very prone to error. Now, there are also ways that you can get the size or length of a string. So what you do, we're going to make an int length. We're going to set that equal to read.size. Now, if we count length, we run our program, boom, it'll print out how long hello is. 5 letters, 1, 2, 3, 4, 5, boom, done. So you can get the length of strings, so you can add on to strings in your program if you need to, and then you can get the length of a string. So here's some more stuff you can do with strings. Super easy. We're going to use that same string, greet hello. Here's what you can do. Let's make another string. String Bob equals quarter. All right, we have our new string. Now what we can do is we can say string, we'll print that. going to print that just because. All right, now what we can do is we can say string combo is equal to Bob plus greet. So now that should print quarter hello. And actually, if you want to add even more to it, you can add a space in between by doing another plus and doing a space and then just leaving it like that, because that will add a space in between Bob and greet. Now if we print that, boom, we want to print that. Ready? It's going to compile. Boom, hello, quarter, quarter, hello. Pretty nifty. All right, there are a bunch of other cool things you can do with strings too. So you can also, in addition to adding strings together, you can also remove specific items in strings. So we're going to make a new string. We'll call this sentence. We're going to set it equal to this string is a super long sentence that matter at all. Done. Nice long string. All right. Count sentence. All right. So now what we can do is we can remove specific items. So if we do sentence.erase, and let's say we want to remove the first word. So that's 0. Remember, index of anything in computers is always going to be 0. So if you want to erase the first letter of something or the first number in a sequence, always do 0 as what you're setting it as. So this is going to be the first number. So this is going to be the start of what you want to erase. And then the second one is not inclusive. So the first number you'd write, which is going to be the start of what you're erasing, is inclusive. So if you do 0, it's going to erase 0. But if I do 2 here, it's going to also erase 1, but it won't erase the character at index 2 in the string. So we want to do 0, comma, 1, 2, 3, 4. So we want to do 0, comma, 4, and that'll erase the first 4 letters in the string. And then we can do sentence, and then we're going to count sentence again. So all we got to do, run the code. Boom. This is now gone. This string is a super long sentence that doesn't matter at all. String is a super long sentence that doesn't matter at all. Boom. All right, so now we're going to start on math and more complex operations. There's lots of different ways to do math in C++, but there are specific symbols you need to use and specific methods sometimes you need to use in order to perform specific actions like exponents and division and square roots and such. So here's what we're going to do. We are going to start with the super easy stuff. So start with your basic program, int main, using namespace std, include iostream, all that good stuff. Now what we're going to do is we're going to do float. We're going to make a float, numbers equals 100, numbers equal to numbers plus 10. That sets numbers, so now number is going to be equal to number plus 10, so it's going to be equal to 110. So, pretty simple, right? Adds 10 to the initial 100. We count that number. We'll count it up here too. All right. Boom, we run that program. 100, 110. Pretty cool, huh? So, next. So another thing you can do is you can do number plus plus if you want to add a number. So instead of, if you want to add 1. So instead of doing number is equal to number plus 1, you can just do number plus plus. Saves a lot of time when you're coding. Super easy. So if we want to do number plus plus, count number, quote, backslash, n, quote, parentheses, we want to run the program. Boom. So it's going to be 100, 110, 100, 101. Pretty cool, huh? So another even easier way to add other numbers other than just 1 is you can do number plus equals, and then say 32. All right, so it should say 33 afterward. We're going to count that. Boom. Run the program. Boom, 133. Super, super, super easy. Now that we've got all that, we're going to manipulate number even more. So number is equal to square root number. So that's going to give us the square root. Hold on, let's see, 144. So let's add up to make it a perfect square root so we will know the answer. Number plus equals 33, 44, so that is 11. Perfect. Plus equals 11. That's bothering me. Okay, we're going to count that just to make sure. Boom. Going to count it again down here for this guy. Number is equal to, oh, nope, my bad. Count number \n. Boom. Run the code. Oh, I forgot something. So, if you're going to do any of the more complicated operations like square root or squared or anything like that, anything where you have to type letters to do it, you want to do hashtag include. Instead of IOStream, we're going to include CMath. All right, cool. Now we run it. I forgot a semicolon. Now we actually run it. Pretty cool here. Boom, 12 gave us the square root. So you want to get the power number, super simple. All you got to do, number is equal to pow, number, comma, and then whatever you want to put it up to. So if you want to do, let's square the number just because we know what 12 squared is. We're going to count that again. Boom, super easy. And it's going to take us right back up to 144. The value of pi is also stored. So if you want to set number equal to m underscore, and you do pi in all caps, count number run the code, and then it will be equal to pi. 3.14159, look at that. So next thing we're going to do is inputs. We've already used cout or count for outputting the console, but we need to have inputs. And even according to the book on page 134, there's nothing quite as satisfying as creating a program that responds to you. This basic user interaction is one of the most taught aspects of any language, and with it you're able to do much more than simply greet the user by name. So generally the first thing you want to do when you have one of these super cool inputs, outputs, here's what we're going to be doing. All you got to do, create your basic program. You don't have to include the math if you don't want to. I just used the same program from last time. So all you got to do is int age. You don't have to set it, don't set it equal to anything yet. You can set it equal to 0 if you want. Doesn't really matter here. Just declare the variable. You can set count, cout, what is your age? And then we're going to do \n here. Then we're going to do sin. See how the arrows go the other direction this time, age, and then that will set whatever sin is, whatever you put in to the prompt is going to set as age. And then we do count. You want to do \n here because it won't do a new line after you type in your number. So you want to put your new line, and then you are, and you can do age, years old. Boom. And then that will be able to, you input your age, it outputs your age. So we're going to say that our age is 1,001,372. Boom! 1,372 years old. Not sure what happened with that. That was weird. So there's a problem with sin. The main problem is that it doesn't allow you to put sentences, because it counts a space as a termination. So once you do a space, it counts as you putting enter in. So here's what we're going to do. Here's how we're going to fix that. String r-ing name sentence. Going to declare that. So we're going to do cout. Write a sentence. /n. So once we've done this, we're going to go to get line sin. So that tells you it's an input, and then you want to put your variable here. So sentence. It doesn't have to be already declared. It will create a new variable if it hasn't been declared. Never mind. Ignore that. We'll just start over again. So once you have your sentence declared, once you have a variable declared, all you got to do, get line sin for input, and then you want to do sentence or whatever your variable happened to be. And then we're going to cout. Remember, do \n after every get line, otherwise it won't start a new line. Or every sin. So here's what we're going to do now. You ready? We are going to do your sentence was \n, and then we're going to do sentence. Boom. Now, we run our code. This is a super duper long sentence that no one cares about. Boom. Your sentence is a super duper long sentence that no one cares about. Boom. You can take in and print large strings with this thing, with this particular get line. I think that the best thing to do is get line for any kind of string inputs. Aside from non-string inputs, you should be using getLine. All right, so another important part of C++ is defining constants. Constants are exactly what they sound like. They are constant. So for example, the speed of light, c, that's a constant. That's a certain number. Pi is a constant. It's a certain number, but we have a different symbol for it. So here's how we do that. Go back to my other program. Here's what you do. Super simple. At the beginning, generally this is after you do your including and use. You do hashtag again, define length in all caps, 50. We're going to define width as 40, and we are going to define height as 60. Now, here's what we're going to do. Count length Notice how when you define something, generally the rule is you do it in all caps so that you can differentiate it from a variable. When you write a variable with multiple words or multiple parts to it, so like if we wanted to do int change, so like number of times it changed, we would not write it like that. We would write it int change with a capitalized on the second one. That tells the program that it's a variable. Not necessary, but that's generally the rule. Same thing with this. You can do it all lowercase, but you might mix it up with a variable. So you want to make sure you do it all caps. So we're going to print out everything else. Boom. Ready? We print. We run the code. It's going to print all that stuff out. Super cool. So that way you can have a constant. You don't have to define it as a variable. So you can also set commands as constants. For example, define new line as \n. So now, if we wanted to do new line, for example, in any of our code, we wouldn't have to do the quotes every time, we just do new line. New line. New line. Boom, super simple. It's going to do the exact same thing as the other code, but it's much easier to understand because it's written out as a word instead of just a command. All right, now we're going to start talking about loops. Loops are very important for any programming. They're used everywhere. They are the basis of most games, programs, because you're constantly looking for, it's basically how you constantly look for something or how you repeat a certain number of times. First thing we're going to talk about is a while loop. Page 144 of the book. While loops are one of the most popular forms of C++ code looping. They repeatedly run the code contained within the loop while the condition is true. Once it's false, it breaks the loop. So this is useful for example in a game where you're supposed to guess the correct number. What you have to do is it keeps prompting you while the input is not equal to the set number that is the answer. It will keep asking you to guess a number. And then it will say too high or too low, or it won't. It'll just say incorrect, guess again. So while loop, that's just a really basic example. While loops are used everywhere. While loops are generally even used to just start a game. So you have while true. That's just how you start a program, is while true. And then all you do is when you click the close button, it just says false or break. So here we go. We're in a program. All we got to do, we need to create a while loop. We just typed while. Boom. That's while. And then it's going to be a Boolean expression. So for example, num greater than or equal to 30. That will mean that as long as the number is more than or equal to 30, the loop will run. In this example, we're going to do num less than 30. You don't do semicolons at the end of loops. You do brackets. You start more curly brackets. So we're going to count number, num, new line. All right? Num is equal to num plus 1. All right? Pretty simple. We are going to start num int num is equal to, let's do -3. All right? Start num at -3. So, return 0. All right? We run our code. Bada bing, bada boom. So, you don't need to do the return 0 thing. Not sure why I did that. But why is it that it stops at just 29? Shouldn't it go to 30? No, it's while the number is less than 30. Now, if we want to go to 30, we need to put that equal sign there. Equal is after. My mistake. Run it again. Super simple. Now it goes to 30. So you want to make sure you understand that it will not repeat at the number unless it will not go through the loop at the set number unless it is set as equal to. It's very important. Another cool command you can do, if you add include windows.h, all right? What you can do is there's a cool sleep command. So, what you can do is you go sleep 1. What this does is it waits 1 millisecond. So each sleep is 1 millisecond. So if you want to do 1 second, you set it to 1,000. So it's going to count now from 20 to 30 for every second. It's going to add 1. So you can make an easy timer this way if you want. Number 20, what? Oh, forgot to do the plus plus. All right. Forgot a semicolon. Number 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Super cool. It's going to end the program. Done. Yeah. Super simple, super easy way to get a wait in there, a delay if you need to. You can also do countdowns. So you can do it the other way too. So if you want, so num greater than or equal to 0, and we want to do, we're going to start num out at 10. We're going to do num minus minus, which does the same thing as num plus plus, but the other direction. So now it's going to count down from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way down to 0. 1, 0, done. So another important type of loop in coding is a for loop. For loops are basically when you want something to iterate a certain number of times. While loops is one way to do that, but generally those are for much larger, that encompass an entire section of the program. For loops are more like you want to print 1 through 5. And then you say so for loops are another very important part of programming. While loops are generally used as an overall encompassing loop, like for an entire program. They generally are used to terminate the program, so you set to false when you want to terminate the program. But for loops are more if you want to count up to 30 and print it, as opposed to using a while loop. For loops are much easier for doing that. They use a lot less lines of code and they execute quicker. So here's what you do for a for loop. Here's our while loop as it is right now. All you do, for, and then what you want to do is you want to you're going to initiate a variable. So int I is equal to 0. Okay. This is going to be like a counter kind of. So I is equal to 0. While I is less than 30, I plus plus. So basically that means that every time the loop initiates, it will add 1 to I until I is 30 and then it will stop. So what we do, we go num plus plus, all right? Then we do, we're gonna count that, num. So loop will repeat until I is 30. Now, it's very important to understand that it is not until num is 30. You can set that up to where you want it to be num is 30 from where num can be any number. All you have to do is just set int I equal to num, and then that will set the starting value of I equal to num. So we run our code. Super easy, counts up to 30. Now, if you start at I equals 0, it will go up to the less than number. It will repeat 30 times if it's I is less than 30 and you set I to start at 0. If you set I to start at 1 and then set it less than or equal to 30, then it will repeat until it's 30. If you just set I equals to 0 and then I is less than or equal to 30, it will repeat 31 times because it will also repeat for 0. You have to remember that. It's very important. Super simple, last thing we're going to go over. It's if-else loops. If-else loops are basic yes-no questions. So what you can do in your code is you can say if they have the correct, if they guess the correct number, for example, in a number guessing game, then it can say congratulations and terminate the program. Or if it's not correct, that would be the else statement. It will execute a different thing, maybe say try again, and loop the program. So here's what we're going to do. Go back to your program, get rid of anything you don't need. All right, keep int num, set the value to null. Don't give it a value at the start. Here's what we're going to do. While true, okay, this is going to set true. So here's what we're going to do. While true, we want it to print, oh no, not print, my bad, wrong language. What we want to do is we want to say count Guess a number between 1 and 10. Oop, 10. All right. And we're going to do sin num out \n. All right, now what we're going to do, this is the basic thing. It's just going to ask you for a number and set that value of that number to num. So now what we do is we want to do if num is equal to, you want to make sure you put 2 equals in there. All right. Let's say 3 is going to be our number. All right. If num equals 3, break, else, we're going to do count, try again. New line. Okay. Semicolon, can't forget that. I did that wrong. Wrong language. Oopsies. Okay. So, what we've got here, we've got our basic code. So, when we run it, oh, I forgot a darn semicolon. Where is it? Here it is. Yes, more missing semicolons. All right, so run our program. 2, try again. 3, boom. Oh, I forgot to put a correct thing in here. So first, before we do break, we know that that works now. So here's what we're going to do. Before we do break, we're going to do count correct. And we'll do new line. Why not? So, run our program. 5, 7, 10, 3. Correct. Boom. Easy, simple input-output program. If you get it wrong, it gives you an output. If you get it correct, it gives you a different output. So, in conclusion, C++ is a very robust language. I just learned the basics in this program, or I suppose I taught you the basics in this video here. But there's a lot more that you can go into. Most of Unity's script coding is in C++, super easy to learn. All of this is super easy to learn, and it's executable in Windows command prompt. So there's much deeper. You can go much deeper with this. You can execute specific files. You can pull text from files specifically, so you could create a dictionary. It is an incredibly, incredibly diverse language that is really, really good at what it does. It is so flexible, and it was fun to learn.